Well, thank you all for coming. This is always fun for me to talk about Bitcoin, and thanks for organizing, Preston. I've been doing pretty much the same talk since 2014 on the protocol, and Preston wanted to talk about wallets, so I wrote a new one, which is exciting for me. So let's jump in. So there's four main functions of a Bitcoin wallet, and they all sound pretty obvious. As we go through them in detail, you'll see sort of what's unique or how the protocol really works. So the main thing is to manage your private keys, and wallets is really the wrong name. It's a keychain. That's very confusing to an end user. End user wants to see like a traditional PayPal style wallet with a balance and a send button and some sort of receive button. So you make it look like a wallet, but under the hood it's really a keychain, and we'll see what that means. You're validating incoming transactions. So that's the big, if you're selling Ferrari, you don't want to let the person drive away with your car until you're sure that you really got those Bitcoins. In practice, this doesn't really happen, but it's a much more fun example. You create and sign spending transactions, and a good wallet, creating a transaction and signing a transaction are different things. You should be able to pass around an unsigned transaction, say, across an air gap. There's now BIP 174 as a standardized way to do this. And then displaying balance and transaction history. That sort of makes it, kind of wallet functionality. Makes it feel like PayPal or whatever. Yeah. So the first one, private key management. So this is like favorite OG Bitcoiner quote from Andreas Antonopoulos: "Not your keys, not your Bitcoin." If you've seen like the meme that people have done where they play this on loop with music, it's pretty funny. But this is a common misunderstanding. People will say, "Oh, I have Bitcoin at Coinbase," and my reaction is always, "Well, you don't actually have any Bitcoin. You have Bitcoin IOUs, and they might be good for Bitcoin one day." I'm not saying that you shouldn't use Coinbase, but that's the exact same thing that happened to people who had Bitcoin at Mt. Gox. So it's not your keys, it's just not your Bitcoin. And we'll see what this means as we go through. So first, a quick refresher in asymmetric cryptography. You have private keys and public keys. Private keys can sign messages. Anyone with the public key, which corresponds to that private key, can verify that the person who signed the message really did hold the private key. And that signature doesn't reveal the private key. So if you think of a check where like someone signs the check, well, everyone has that signature. Also, cryptographic signatures are tamper-proof. You can't like add a zero at the end like you could on a check. Of course, checks you write out the amount too, but that's all pretty weak forms of a signature. This is much better. And as far as the private key management part, private keys are just 256-bit numbers. For visualizing that, that's 256 one or zeros in a row. Now, of course, you could put it in hexadecimal, or you could use like wallet input format. The larger your key space, the fewer number of characters you'll need. But it's just a big number. And the Bitcoin address is the public key. Put a star there. We'll say why that's not totally true. But you can think of it as the public key. And only the private key can sign a message. Anyone with that private key can spend. And without that private key, you can't. It's not recoverable. So it sort of creates a different paradigm. There's no like PayPal password reset. If someone steals your private key, the Bitcoin network doesn't know it's stolen. They just know a cryptographically valid signature was produced. That's good enough. And each transaction should use a new private key. That's pretty good on the network now, but in the early days, address reuse was really common. Do you guys know why you should use a new address for every transaction? Any guesses?
Traceability, right?
Traceability, privacy. So it's a weak form of privacy because if I'm always having a new address, you can't see all of my funds coming and going. Now you might be able to figure out like, hey, it looks like you have this pot of Bitcoin, and then you sent some little bit here with change back to yourself, so that's still yours, and then you sent some other with change back to yourself. But knowing which one's the spend and which one's the change is not technically knowable, but you might be able to do some sort of like statistical linkage. So that's one reason. Other reason?
I think with the P2PK, it shows your private key, public key. You're like displaying the public key to the network every time you spend from an address.
Exactly. So if we go back to this asterisk here, the Bitcoin addresses are the public key. They're actually not. We hash the public key, then we do some encoding. So in paid public key, it's going to be base 58 encoding, and a checksum, which is like this clever thing. So if you are manually transcribing a Bitcoin address, which honestly you're not really ever going to do that, you're going to use a QR code. But if you were, and you were off by one digit, the checksum would not validate. So the odds that you would get that right, it's a 4-byte checksum. So That's like over 1 in a billion chance that if you mistranscribed, it would still be a valid address. So you do all of this stuff to get the actual Bitcoin address from the public key. And then to what you're saying, when you go to spend, you reveal the public key. So let's say ECDSA was broken. Somebody had found some way to break ECDSA, and they knew your public key and could then find out your private key. Well, that'd be really bad. But if they only know the hash of your public key, you can't reverse that. And so Bitcoin uses both SHA-256 and RIPEMD-160 to hash the public key. So Satoshi was very paranoid, which is a good thing in a cryptographer.
Could you explain again why it's bad for a counterparty to know your actual public key and like why we hash it?
Yeah, so the question is, why is it bad if somebody knows your public key? It's only theoretically bad, but we only reveal the public key at the time of signing a transaction. Up until then, you say, hey, I received Bitcoin on this address. If it's a traditional style address, it's going to be like 1 ABC, it always starts with that leading 1, or if it was PSH, 3 something. Now we have SegWit back 32. But so you have this Bitcoin address. You have no way to reverse the hash function to get to the public key. And then from the public key, obviously the private key. So you have this extra layer of protection that if ECDSA was broken, which nobody expects to happen, a lot of bad things would happen on the internet if ECDSA were broken. But if that happened, and you only have my Bitcoin address, you still couldn't go from my public key to address if you didn't know my public key. So if I use a new address every single transaction, then I'm only going to reveal my public key when I spend those funds. But if I reuse the same address all the time, and then one time I spend some tiny amount, but I've revealed my public key in doing that spending, then I'm a target if ECDSA were broken.
What's the length of an address?
So the address actually varies because of this weird encoding and stuff. But you're doing RIPEMD-160 in that process, so you only have 160 bits of information. But then you add the checksum.
Why RIPEMD?
It's old. There's like weird choices. Like we're using ECDSA instead of Schnorr because Schnorr had just come out of patent at the time. And Schnorr is just a better signature scheme. But ECDSA is bulletproof. There's no new cryptography in Bitcoin. Bitcoin could have been invented a decade sooner. It's kind of like on all of us for not thinking of it sooner. You've got like SHA-256, ECDSA, RIPEMD-160. These are like not new technologies. Key value store, yeah.
So when you do like a pay to public key hash, are you displaying your public key or just the public key hash?
Just the public key hash. And then
so that's
you're
more secure.
Yes. And then you're also base 58 encoding, and you're adding a checksum for that like off by 1 inch.
Okay, so then can you just use the same address then if you're just displaying the public key hash rather than the public key when you spend?
Could you reuse then?
Right, yeah,
Yeah.
is it safe to then reuse?
As far as the if ECDSA were broken case, yeah, you could reuse. But for your privacy, if I tell you, hey, send me Bitcoin, I have address A, and then I tell him, hey, send me Bitcoin, I have address A, now both of you know something about me that if I use 2 different addresses, you wouldn't know. So that's totally allowed. There's no penalty there, but it's just a really bad practice. Okay. But yeah, you can. And people do. Like there are some prolific abusers that are more historical.
I think there's also ways to like guess which is the change address and then like basically create what is it, like a database cluster of addresses and stuff like that.
So there are all types of people doing that analysis, and we'll look at coin selection and building an unsigned transaction in a little bit. But a good wallet randomizes which output is the change and which is the spend. So in a traditional, like if you think of the most basic spend, where I'm going to destroy 1 UTXO, and then I'm going to create 2, 1 to send some Bitcoin to you and 1 to send some Bitcoin back to me. Whether the first one is the spend and the second one is the change back to me, or vice versa, it should be done randomly, so that some person looking at it doesn't just know. In the beginning, there were some wallets that were always like, well, the spend is first and the change is second. But then if you were looking at the network and you knew that this was using wallet X, you would say like, okay, well, then we know which one's the spend and which is the change. But that's a weak, this is not like some sort of fancy like ZK Snark type of thing. This is just, it's a little obfuscation. It's better than none, but it's weak privacy.
Yeah. So I hear about Bitcoin using double SHA-256? Is that just because of that layer of security that you were talking about?
Yeah, so I'm actually, like, there, I put the hand waving star, you actually do double SHA-256. So like fun trivia, when encryption and hashing algorithms are broken, sometimes the solution is just to do them again. It's not like a real solution because it's still a theoretic leak. So I don't know if you guys, you're probably too young to remember DES, the data encryption standard. It's popular before AES. And when they discovered a vulnerability in DES, the world switched to triple DES. And so that's what was being used before AES. And it's sort of like if you have any bit leakage at the beginning or the end of that, either data or ciphertext, by doing the whole process again, you kind of, like, you heavily minimize the impact of it. So double SHA-256 was just Satoshi being paranoid. But it's good, you know, that it's very quick to calculate SHA-256, so no harm in doing it twice. Okay, so there's been a ton of improvements. If you're looking at like an old Bitcoin wallet, like one of those paper wallet generators, all of this stuff is new and better. So if you're making a wallet now, this is the stuff you'd want to do. So in Bitcoin Core v06, which was like 2012-ish, 2013, we switched to compressed public keys, and that just saves a little bit of disk space. If you think of the public key as an X and Y coordinate, you can either give both of those coordinates, or you can say, well, I know the curve, so if I know where the X is, I can calculate the Y. So compressed is just the X coordinate only. So that's a small thing, but it leads to annoyances if you're writing a wallet because you have to handle both cases. HD wallets, these are huge. So remember that we're supposed to use a new address for every transaction. And also that if we lose our private keys, there's no recovery option. So in the beginning, what happened is you had this thing called a key pool, and people would have like 100 Bitcoin private keys and 100 corresponding addresses. Each one is just totally randomly generated, those keys. There's no linkage between them. And you back that up, you know, say in a safe or, you know, bury it in your backyard or whatever you would do to back that file up. Well, as you went through those addresses on your 101st transaction, you'd be using a new address that was not in your backup. So you'd have to go into your yard and dig up your USB drive and update it with the new stuff. And obviously that's really impractical. So HD wallets stands for Hierarchical Deterministic Wallet, and you take some master secret, and from that you derive a bunch of addresses. So in the case of an HD wallet, I think the limit is like 2 billion. So you should be able to set this up once, back it up however you want, you know, bury it in your yard, put it in your safe deposit box, divide it up in pieces and store it with friends, and then you're set for the rest of your life, which is pretty cool. But then the issue is you have these really long strings. I use the word xpriv because they start with xpriv, and they're like really hard to memorize. So mnemonics came around, that's BIP39. So if you're used to like Electrum or Bread Wallet type address where you have, you know, correct horse battery stapler, your words, that's really cool because you can just memorize that, put that into any wallet that's compatible, and it will generate all your keys and all your corresponding addresses. So that's like if you're, you know, Jason Bourne washing up on a shore somewhere, unconscious, with no, you know, nothing on you, but you have this one seed, you could find a computer and have all your Bitcoin. You know, in case that's your use case. Or more realistically, you're like fleeing an oppressive regime. That's pretty cool that you just have these words in your head and no one knows you have. Then BIP44 came along to standardize the derivation paths. So as you're navigating this hierarchical deterministic tree, you have to decide like where does the change go and where do incoming transactions go. And without a standard for that, different wallets were doing different things, they're not compatible. Developers would sometimes be like, you know, what was the gap between addresses, or do I start on the 32nd address was a popular thing for BIP32, but not standard. So BIP44 made that standardized. And most recently, we've got BEC32 native SegWit addresses. We'll talk more about SegWit later, but basically a lot of different address types you have to get right. And then the really big improvement, another really big one is hardware wallets like Trezor and Ledger that make some of the more secure stuff more accessible. I do have some beef with these, so I'm not saying that they're perfect, but it is a step forward.
Which one's the better one, in your opinion?
I like the buttons on the Trezor better. So I think if you're gonna try to type something in, and you should be, you know, that's a core part of using it, then I think that's pretty important. But I'm looking for something better than both. I wouldn't go so far as to recommend either one.
What's missing from,
We're gonna get to a whole section at the end on what's missing. So I was playing around yesterday morning with a hardware wallet that someone's making that's not yet released. That's like really exciting. I want there to be more competitors. I want something that's like open source, that supports a bunch of other security features, but we're gonna get to that at the end. Okay, so next step in the wallet, very obvious one, validate incoming transactions. And there's 3 ways to know if you've received funds. One is a full blockchain validation, sometimes called full node. That's you just validate everything on the network, and you look at each transaction and say, hey, am I a party to this transaction? Am I sending or receiving? And if I am, hey, I know this is real because I connected to the peer-to-peer network, I validated the proof of work, I validated the consensus rules, and here's my transaction. So that's pretty good. I didn't have to trust anyone. It does mean I have to, you know, it's not gonna work on your phone, and that has some limitations. The next option is SPV, simple payment verification. And this is really cool because I'm able to validate from the block headers the difficulty, meaning the proof of work was done, and that my transaction was included. Now, SPV proofs only give us proof of inclusion. There's no proof of exclusion. So that's good enough for validating an incoming transaction, because in the case of like someone driving away with my car that just paid me Bitcoin, if they paid me money and I'm not able to validate it, we'll just wait longer until we sort it out. But I'm not gonna let them drive away with the car until I have proof that that transaction was included. But there's some big buts about doing this. We're gonna see some privacy issues involved. I'm gonna have to rely on some third-party service to tell me about my addresses. And I'm trusting that the work is a measure of the consensus rules. So in the case of a hard fork, how do you know which chain to follow? You know, if you look at Bitcoin and then you compare it to something like ABC or SV or Pizza or Diamond or Faith or any of these Bitcoin so-called hard fork airdrops, they all have the same headers. So how could you tell which chain you were on? How would you even know what was the right one? If you're running your full node, well, there is no ambiguity. Your full node is always correct because it is by definition correct. So once you step away from the full node, you have this ambiguity that you could be on the wrong side of things. You also have to think about your attacker. You know, is your attacker trying to fork the whole Bitcoin network to steal your like beat up Honda? Probably not. That one's probably okay. And then the third option is a fully trusted server, and you know, that could be anything from a Coinbase wallet where you don't really have the keys to another wallet where maybe they're not doing like a proof of inclusion because they don't need to, or they're not validating it because they're trusting their own server anyway. Okay, so this is other big core element. You've got the private key management. Now you have to create and sign spending transactions. And so this is where we get to a UTXO selection. And this is a tricky one because you have a balance of privacy versus fees. So we talked about reusing an address, and then you don't have any of the privacy component because, well, it's all on the same address. It's obviously controlled by the same address. But let's say you have a bunch of different UTXOs. And UTXO, if you're not familiar with this, is unconfirmed transaction output. And that's what a Bitcoin is. Owning Bitcoin is being able to unencumber a UTXO. So let's say you've got a bunch of these, you know, one from address A and from B and C, and maybe for some silly reason you have 2 at D. Sometimes you say to somebody, hey, you know, pay me a Bitcoin to address A, and instead of sending you 1 Bitcoin, they send you a half a Bitcoin twice. And so maybe you would have 2 UTXOs on address D, for example. So now I have to pay somebody else, say, a quarter of a Bitcoin. I have to look through all my UTXOs and say, which ones do I want to choose? You know, maybe I have this address that has 0.26 Bitcoin, and I have to pay 0.25, and that just makes so much sense. I'll pay the 0.26, I'll destroy that, and create 0.25 and 0.1 back to myself, and I'm fudging for the fee. Take a little out for the fee. Maybe I have that, but maybe I want to consolidate my UTXOs. Maybe fees are low right now, and I want to combine all of them into one new output. But then that's going to give up some of my privacy because I had all these different transactions with all these different parties. Maybe some of them KYC'd me. So now I'm linking all that together. So that's a really tricky problem. There's the decision of privacy versus fees, and then there's sometimes users' own coin control, where they might not want to blend like maybe work, company funds versus personal funds. So that's a tricky one from both the UX and the privacy fees trade-off. But using some algorithm, you generate this skeleton of the inputs and the outputs. And remember, all inputs are destroyed in a Bitcoin transaction. So if you think of like a regular cash transaction where, say I'm buying something for $9, and I hand them a 10, and they give me a 1 back, Bitcoin's the same thing, only these inputs are whatever size I happen to have, and the outputs, we can create them. So I could pay with, a 10 millibitcoin UTXO, and I could get back a 1 millibitcoin UTXO, and they could keep, I could send them 9 and send myself 1, and I could destroy my 10 that way. Again, hand waving away the fee, which is going to be so small. So once you've created this unsigned transaction object, you sign each input, and that's sort of confusing wording, but you have to come up with the right fee for this whole transaction. So we do that, and our fee is the sum of the outputs minus the sum of the inputs. It's the leftover. So you really want to get that part right. There's no like specified fee field in a transaction. And so some transactions have mistakenly paid 100 Bitcoin fees before for getting this wrong, which totally sucks for them. Some
I think
mindfuls.
one happened recently.
Oh, did it?
Yeah, there's like a $1.3 million fee.
Oops.
I heard that was actually like something to do with compensating miners, like it was,
That's right,
it
yeah.
was like someone's intentionally paid to have a fee because they knew a specific miner would end up catching the transaction.
Huh.
Yeah, if you knew a specific miner would catch a transaction, that could be a way of funneling payment to just in the fee.
Lawn money laundering or something?
Yeah.
It's a matter of setting the fee correctly, just analyzing the current state of the market, like the fee market.
Yeah, so you can look at what the number of Satoshis per byte that people are paying to get in blocks, and it's inherently imperfect. So you can either look at your own mempool and do some analysis, like, well, I'm seeing all these transactions, and so I think this is what it looks like. But remember, you may only be seeing a partition of the network. There's no guarantee that what you're seeing, everyone else is seeing. And you're only seeing the network right now. Maybe the next block isn't found for 20 minutes, and in that time, your fee becomes not nearly enough. So we'll talk about the fee part in a bit. That is tricky. And then, oh, sorry, can we go back? And then when you sign the input, you need a good source of randomness for your K value. There's this spec RFC 6979 that most wallets use, deterministic K value. That's just what you should do, but if you look back to like 2013, there was the secure random, I should put that in quotes, secure random bug in Android's implementation of their random number generator, and a lot of people lost money that way. So if you don't have a truly random K value, your Bitcoin can be stolen, which is scary. And then you have to broadcast it to the network. So the last function is balance and transaction history, and this one's pretty straightforward. Similar idea between a full node, a light client, and a trusted server, but I thought I would break down the light client a little bit. So you can do simple payment verification, that's the Merkle proof of inclusion. You can do Bloom filter, which is BIP37, which is live and active on the network, nobody uses it, and it doesn't have great privacy. But it is a neat way to query nodes for information about addresses without saying specifically which addresses you care about. But they can probably figure out like, oh, it's interesting that you want to know about this Bloom filter and this Bloom filter. Like these queries tell me you're probably interested in this address. So it's kind of a bad protocol, and it also has some denial of service vectors. They're not good. And then Neutrino is coming soon, which is, they're sometimes called compact block filtering, and that's a cool protocol.
Did Coinbase acquire Neutrino?
What's it?
Did Coinbase acquire Neutrino?
Oh, Coinbase just takes names for all kinds of stuff. So like the Genesis block is called the Coinbase, and they named themselves Coinbase. And then there's a company, they might have bought a company called Neutrino, but the Neutrino protocol is an independent thing. And it's a different type of filtering that's done client side instead of with a different Bloom filter for every client.
That's to mask the transaction that you're asking for, correct?
Exactly. So everyone, it's just a different, it's a totally different algorithm.
It is.
And so the way it works is, well, currently it's only on testnet, and we'll see if it gets software into Bitcoin. But the idea is that everyone sees the exact same filter. So there is like a published filter for every block, and then I can look and see if my transactions are in there. If they are, then I have to request the whole block. But that's already something that I can do to any node on the network, where I can just say like, hey, give me block X. And then I can go to some other node and be like, give me block Y. And so probably you're not gonna be able to figure out that because I care about these two blocks, where are the overlapping addresses in them, because I got them from two different places. But there is some more network in this that I'm gonna request whole blocks when I only care about one transaction. So it's a trade-off, but it's just better. Yeah.
So with simple payment verification, is there like a list of nodes that are publicly accessible to anybody that are like trusted by Bitcoin or something like that?
Yeah, so it depends on the implementation. So SPV is usually Electrum, which is sort of its own thing running on top of Bitcoin. So if you use like the Electrum wallet, an Electrum server indexes Bitcoin addresses on top of a Bitcoin core node.
Oh, so it
And-
runs a node in the background?
Yeah, it has to be running on top of its own node. So like if you want to have your own Electrum where you're not if you want to use Electrum but not leak privacy, you'd have to run a Bitcoin Core full node, an Electrum server on top of that that's going to rip through all the blocks and index all the addresses, and then query your Electrum server.
So you're not querying like external nodes? Is that like possible?
If you're doing SPV, you're querying Electrum servers that are indexing on top of nodes, but they're not the node themselves. There's like a.
But in external though, I mean, like?
You can also query your own Electrum server. So you could like, so that is a very cool way to do it. I know, like for example, some exchanges that do that for their cold storage. And we'll get to that because Electrum has a good air gap, which is nice. And then the last one is just a trusted server that just tells you like, this is your balance. And the balance, we're used to seeing it like, you have this number, 1 Bitcoin, but it's actually the sum of all the incoming transactions minus all the outputs that you spent. And that's actually could be like a lot of work for you if you were trying to look at it, because you would constantly be looking at transactions where you're like, well, if these funds came into A, and then they were sent to B, but some change went back to C, and then C spent to D, but there was change to E, like, it would be unclear to you as a person looking through with all these random looking numbers of addresses what your balance was. But obviously the computer just keeps track of it all. It shows you one balance. But it's a collection of UTXOs available. Okay, now we get to the fun parts, the areas for improvement. So the really big one is security. It's crazy to me that a decade into Bitcoin, security is still such a big problem. And so the number one thing that I look for is an air gap. If you don't want to keep your Bitcoin on a hot machine, something connected to the internet, you need some external thing that is the buffer between the internet and your private keys. An air gap is great for that. Unfortunately, nobody has a great one. And QR codes can only carry so much information. Signatures are big. So if you have a transaction with like 4 inputs, it can be hard to transmit it via an air gap. There are different ways these work, like if you use a Trezor or Ledger, you plug that into your hot machine that we assume is compromised. That's why we have the Trezor or Ledger in the first place. And then it updates the firmware on the device, and then the device, you hit yes to sign. So I really dislike that about it, especially because you are not the one loading that software on in the first place. It's not some commodity hardware that you just put open source software on. So that's a little scary, but it has a place. And that brings me to the next one, which is building from source. A lot of these, like, there are people selling fake Trezors and Ledgers on eBay, which is just brilliant. Or preloading them with a seed. That's even easier. Kind of clever to give it to them for that. The other one that I don't see a lot of that I think is super important is Shamir's secret sharing scheme for backups. Shamir's secret sharing scheme is like this really cool thing, and the original paper from the 70s is 2 pages long. It's pretty easily digestible. And you can split a secret into M of n parts. So, for example, for my Bitcoin, I do 6 of 11, and I keep that with 11 people that I trust, and any 6 of them can combine to get this password to a USB drive. So that's like a very, very cool thing, that no one of them has access. It would be incredibly hard to like find these 6 of these people and find where they keep their stuff, and in all of that, you just get a password to a USB drive anyway. And now with HD wallets, there's better setups you could do for that. But if you're not using Shamir's secret sharing scheme, your Bitcoins are almost certainly at risk. And the 2 risks, one is that you're leaving private key material unencrypted. So like if somebody were to get access to that, they could spend your coins. The other risk is that you have a password and you're the only one that knows it. And so the only way you can mitigate both of those risks effectively, I think, is Shamir's secret sharing scheme. I would love to see more adoption of it, and it's not used very much. Another one is encrypting your private key material and storage. There's a BIP for this. So BIP 39, which is the one that does mnemonics, also has a passphrase option. So that's a really cool one. Like you could use a crypto steal, put your mnemonic on that crypto steal, and then have a password that is maybe long and in your head, I should say passphrase, and then use Shamir's secret sharing scheme to break that up. So you can have that crypto steal in a couple places. If anyone found one, they don't have the passphrase. BIP 39 has a cool plausible deniability in that you could have multiple passphrases, and maybe one of them is like a decoy, so it only has a small amount of funds in it. So that's like extra cool. And then I'd love to see more complicated scripts. So like, if you look at sidechains, Blockstream sidechains, the way they do recovery, if no transaction happens for a certain amount of time, I think it's a month, then they have a 2 of 3 that can recover the funds. So that's like a clever mechanism where that can have a different security model, because those keys will only work situationally. And so that could be like a clever one. And I think as we see more advances in Bitcoin scripting, then you're going to want to have more complicated scripts. And most wallets just do the most basic scripts. Multisig or pay-to-script hash is another obvious one. If you have more than one key, then you don't have as much of a single point of failure. Although you have extra complexity, if you're claiming airdrop coins, although who knows if we're going to keep seeing those, that can make it harder. And then, this is a silly small one, but user-supplied entropy on seed generation. If you boot a virtual machine up and then use its random number generator to create your seed, well, that might be reproducible. So you would want to have some, like, think user banging on the keyboard. Or a really cool one, if the hardware wallet has a camera, you can just take a picture of anything and use that as your entropy. No one will ever take that same picture again. So those are some security ones, yeah.
The difference between multi-sig and the secret sharing scheme.
Yes.
So the secret sharing scheme has one key?
So secret sharing scheme takes a key and splits it into M of n parts. And that is something that if people were doing, the network would never know. Because when you recombine them, it's just one key, one signature. With multisig, or the implementation now is pay-to-script hash, with Schnorr, if we get Schnorr, maybe things will change. But with multisig, you will see on the network, like this is an address that takes 2 of these 3 keys to sign, and here are the 2 that did the signing. So it has some benefits because you don't have like one device where the signing is happening. You could have like, one office in your home or something. You could have different people holding the keys, so no one can say, like there's no deniability about who did the signing. With Shamir's secret sharing scheme, you could have like this M of n people, and the funds go missing, and all of them say, well, it wasn't me, it must have been someone else. But with P2SH, you would say, okay, well, it was 2 of 3 of these keys, or 3 of 5 of these keys, and we know key A was Alice, and B was Bob, and C was Charlie, D was David, and we know that it was Alice and Bob's keys that were used. So Alice and Bob might still say, oh, someone broke into my house in the middle of the night, but at least you know who did the signing. From the network's perspective, seeing more signatures is not ideal. Because if you're a miner, you have to validate 2 signatures or 3 signatures instead of just the 1. So there is a trade-off there, which Schnorr is more efficient on.
For secret sharing, are you literally chopping up like sections of your private key, or is it more complicated?
It's more complicated, which is important. So if you do M of n and you get M minus 1 Shamir shares, you have nothing of value. Whereas like if you take the simplest case of chopping up a piece of paper, let's say you have let's make the numbers interesting. Let's say you have an 80-bit private key, or an 80-bit secret, which you shouldn't, that's too short, but let's say you did, that's longer than most people's passwords for most things, and you cut it in half, and somebody came across half of your key. So they have 40 bits, and they're missing 40 more bits of ciphertext, or password, or private key material. 40 bits is brute forceable. It's not cheap, but it's doable. So that's really bad, because now, effectively, if someone finds either half of that, you're done. And so you just made it worse, like you should have stored the whole thing in both places almost. You made it complicated, but you didn't make it more secure. Now maybe your attacker is like not sophisticated, but you should assume your attacker knows more than you do. So if you use something like Shamir Secret Sharing Scheme, and you did 2 of 2, then if you got half of it, it wouldn't get you anywhere.
Okay.
And you could do 2 of 10 or 2 of 100, you can set your threshold, whatever you want,
Gotcha.
depending on your use case. So it's a really neat one to layer on top. So you could combine that with multisig. So you might have 2 of 3 keys, and one of them maybe you store not super securely, like it's in a vault, but it's not encrypted. And one of them you store really securely, but you split that many ways, so you can recover it. So there's like cool combinations you can do. It's too bad there's not a standard, because if there was a really good standard, which I could see us getting in the future, then it would be easy to import these things. You wouldn't be worried about messing it up. A lot of the Shamir Secret Sharing Scheme libraries are not well reviewed, so that's scary. But it's a cool trick. It's like, the first time I heard about it, it's what PayPal was using to store their database of credit card numbers. So that's something where like you don't want it sitting around unencrypted, you don't want someone losing the password, but if you can have M of N of your engineering staff get together, then you can decrypt the database of passwords, or of credit card numbers. So that's pretty cool.
When you talk about setting standards, this is kind of a general question. When you talk about setting standards for like stuff like that, like the Lightning Network, like it's all these different like new protocols, like just sets of like modular code that people just happen to adopt. Like there's just a lot of people using it, so it just like becomes the standard.
Yeah, I mean, it's sort of vague, like what makes something definitely standard. Like if it's part of the consensus rules, then it's part of Bitcoin for sure.
Right.
But like BIP32, you can't tell on the network if a Bitcoin address was part of an HD wallet. You can't even tell. And then even if you knew it was part of an HD wallet, say because like it was your address and you told me that, I still couldn't tell whether you used BIP32 or whether you used a like Armory style HD wallet or a, before there was a brief moment of SD wallets. I forget what the S stood for, but it was a different protocol for deriving wallet addresses. But the Bitcoin network doesn't care. It just cares that the signature is valid. So that's something that sort of like sits on top. So you can have something similar, like you have these other BIPs for using Shamir Secret Sharing Scheme.
Right, so like you could do the secret sharing scheme now, it would just be really cumbersome, and having a standard would just have like this code that, like it's helpful code, but just the fact that everyone's using it just makes it like really easy to use.
Yeah, so
That's
you
how
would
it
get
becomes
the
standard.
ease of use, like, so you get hit by a bus, and they go into your safe, and they find like some USB drive, and it's okay, what did he do? Like, maybe there's a README file, but like that's not easy for, you know, maybe a less tech savvy audience to figure out. But if you have a standard, like if you had a paper wallet and it was wallet input format, WIF, super standard, any Bitcoin wallet, almost anyone should scan that and import the private key on that. So imagine there was some like standard that was implemented in a bunch of languages and wallets. And then by becoming a standard, it would be super debated. And people would say, well, maybe I don't like this proposal or that proposal. So you get more eyeballs on it, like better testing. Right now, people just kind of roll their own, and that's always a bad idea. But maybe it's better than nothing, I don't know. Okay, so privacy. So there's input selection for the fee, and also just, you know, which inputs do you want to use, because maybe you want to have less UTXOs for blockchain bloat. And then there's coin control, that maybe you have like your business stuff and your personal stuff, and you want to keep those separate. There's also when you request transaction info. So you're querying out to some server saying like, hey, give me all the transactions for address X. Or maybe you're using a Bloom filter, but they're able to figure out what you want. So that's one you could run your own server to query against, but that's obviously a pain. And then when you go to broadcast transactions, if the network first hears of a transaction coming from you, then it's quite possible that you were the one that signed that transaction. So you maybe revealed that info. And if you guys remember blockchain.info in like I want to say it was 13 or 14, they were showing the IP address where a transaction was first seen on the network. And it was causing some real problems because say like a law enforcement officer is doing some investigation on a transaction that was used in Silk Road or some nefarious thing. And they go to blockchain.info, and blockchain.info would say, oh, we first saw this transaction coming from this IP address. But that IP address was just some person running a node who broadcasted it to blockchain.info and a bunch of other peers. But they were the first one, they got it from somebody else. And now the police show up knocking on their door for running a Bitcoin node. I believe blockchain.info no longer displays that IP address. But, so there's this Dandelion protocol, it's BIP 156. We'll see if that gets implemented. That's a way to try to obfuscate that. And then CoinJoin is a really cool one where a bunch of people combine inputs and outputs to mask. But again, it's a weaker form of privacy. Maybe those bunches of people are actually just the NSA running CoinJoin servers. It would be kind of funny because they would be, if they were participating in something like a join market, then they would be making money by de-anonymizing Bitcoin traffic. So they would have like an incentive. You can't know who's on the other end of that. Now there's some privacy minimization techniques in CoinJoin, and there's newer CoinJoin stuff, CoinShuffle and stuff. But again, it's all weak privacy. None of it is like a ZK Snark or anything. Fee calculations. So fees are really annoying. We talked about it a little bit before. But the basic things you can do are batching outputs. Why does batching outputs for most wallets have minimal impact? Anyone know why? So for most users, it's just not a normal use case. Like there are some businesses, exchanges are super well known for this, that have to pay multiple people in one transaction. But most people aren't transacting with that kind of volume. The other one is that the signatures on the inputs are the things that take up the most space. SegWit segregates the signatures, so that changes. There's a discount for that witness information. But still, that's the big one, so you can't really escape that, but at least you can minimize a little bit. And there's a privacy issue. If you're batching transactions, then it's sort of more known, like, hey, this one entity paid all of these people. So if I can find out who any of these people are, I can find out who this entity was. So it's sort of a privacy fee trade-off. And then there's transaction priority, like maybe you want to be in the next block, that's super important to you. Maybe you don't care if this transaction takes an hour. So that's a UI thing that now a lot of wallets do correctly, where they kind of show you, give you a slider, or they do some sort of estimation. But the really big one, since you're never going to be perfect about it, is what happens when you're not. And for that, you have RBF, replaced by fee, sometimes called bump fee, and CPFB, child pays for parent. So in RBF, you designate that a transaction can be bumped, which could be scary to the recipient. Their wallet might say like, hey, wait a minute, why is this person potentially going to double spend this transaction? And then if you need to, you're able to increase the fee amount. So this is really clever for paying the least amount of fee and only having that one transaction ever make it into the blockchain. But most wallets, unfortunately, don't support it. Oh, I wrote RBP. That should say RBF, replaced by fee. And then with child pays for parent, if you have a transaction that's stalled out, the fee is not high enough, you take one of those outputs and you make another transaction with it, and you do a really big fee to cover both of them. And so that's the other way you can do it. Obviously, both are not ideal, but you don't want to be stuck in a situation where your transaction stalled out and your software doesn't know what to do. That's like the worst UI ever. Yeah.
Why do you have to indicate that you may double spend before you do so? Like, can't you just double spend and then whichever one has the higher fees?
Yeah, so I think it's just a node, looking for the right word choice, everything's so political now, like these were major contentious issues. Cash, for example, ABC and SV do not support RBF, because that was a change that was controversial. So this is non-consensus policy. I can't know what your policy is on unconfirmed transactions because by definition, they're not confirmed. And so you could tell me like, oh sure, if you pay me more, I'll include it. But I wouldn't know whether you're being honest or not. I have no reason to think that you'd be lying, but imagine that this was a really big amount on the line. Imagine this was a $100 million transaction, and you said, oh yeah, I got it, it's in my mempool, it's just as good as confirmed. You can go ahead and release that gold shipment now. I'd say like, well, I want to see it confirmed in the network. So the Bitcoin Core software, by default, if you designate this field, then if it sees a higher transaction, it will bump it from the mempool. So that's like a non-consensus rule that we assume people are following. But really, to be sure, we have to wait until there's confirmations, because that's when work is involved. So there's always that tension with unconfirmed transactions. If you want to do unconfirmed transaction, Lightning is fantastic, because you can do like true zero conf.
But so this is done automatically, like I don't have to like specify like I may double spend. I can just try and see like whichever one gets confirmed first. Right?
Yeah, the reality is most wallets don't mark it as eligible for RBF, because most wallets just don't implement a lot of stuff.
But would they stop me from attempting? They probably would.
The wallet most likely would, but if you control because the wallet just wouldn't be written to double spend,
Yeah.
because if that were misused, like you would look like you were trying to attack an exchange, and then they would keep your funds, and then you would blame your wallet. So by default, it probably wouldn't let you, but like there are scripts online where you can put in your private key and do this.
Yeah, I think I have done it before because I mean, back in December I couldn't get anything confirmed, so I just had to keep double spending until the transaction fee was enough or something. So
Yeah, and you want to be really careful if you're doing that with an exchange, because they might have some automated thing that just says like, whoa, transaction from person A, they're trying to double spend it. Now maybe you've just bumped the fee and you're still sending them the same amount of Bitcoins, but their automated system may not be that smart. A lot of people weren't used to writing code to handle this because fees had always been so cheap for so long that they never really tried or optimized or worked on the UI on that. And it's sort of a harder thing to test too. But yeah, you may have just had to bump your own fee, or more likely do a child pays for parent, where you took the output that was yours, that was also unconfirmed, and spent that on probably to yourself with a huge fee. And then that would give you the first one. But that's extra bad for the network, because now the network has to process 2 transactions during a time of fee congestion, and you're definitely going to overpay the second time because you're in panic mode. And so that's going to bump the fee estimation up for everyone, because everyone's going to see like, oh wow, look at that huge fee, that's what the market must be now. So RBF is better and not really used much, but I think it will be more in the future. And then you have to think about other coins when you do a Bitcoin wallet. So there are these hard fork airdrops, like ABC and SV are the most common one, but Bitcoin Gold. But then there's like these silly ones like Pizza and Fake and Diamond. So these are really tricky with privacy, because if you want to support all these coins, if you wrote a wallet and somebody says, okay, give me my Bitcoin Gold, then they're going to send all of their UTXOs for Bitcoin Gold to one address, most likely, on an exchange somewhere. A lot of exchanges won't give you multiple addresses. And they're going to have to query this blockchain data for somewhere, like are you going to make your software compatible with a Bitcoin Gold full node, watch only? And that's like complicated. And then if you delay releasing support for that coin, that's a really bad user experience. People are going to be screaming, give me my Bitcoin Gold, you've locked it up in your wallet, I can't get it. And if you have support quickly, well, it's really dangerous. What if there's some bug in your implementation or their protocol? This software is designed to be holding private keys. And that's just for the Bitcoin hard fork airdrops. What about altcoin support? And in 2017, consumers were really demanding this. So if your wallet didn't have support for their altcoin, they would switch to a different wallet. And then you had the same problem of releasing support for these coins when it wasn't that well tested. So now your wallet is getting like regular updates too, so that becomes an attack vector on your wallet security. So this is unfortunately just kind of a tricky thing. Maybe we'll see that these airdrops are no more, and so if you're a Bitcoiner and a Bitcoiner only, you don't have to really deal with this. But a lot of developers kind of got caught on their heels in 2017. And one of my favorite quotes, there are no bailouts in Bitcoin, so all this stuff's complicated and don't mess it up. And that's it. And I don't know how much time we have room for, but I'm happy to stick around for as many questions as we got.
I got one right off the bat. What is the importance more generally of full nodes or running a full node? Like, does it make the network like more robust in a way, or it keeps the miners in check? I've heard, but I just kind of wanted to get your.
Yeah, this is like super, so the question is like why the emphasis on running a full node, and it's a super controversial topic. So there are people who say like you have to run a Bitcoin Core node, and if you're not participating in the ecosystem. And there are a couple of different reasons why it's tricky. So one is, let's say you're running one implementation, say a full node, and I'm running some light client, and there's some disagreement. And there's a lot of bugs in Bitcoin. If you're going to try to duplicate Bitcoin, you have to be bug for bug compatible. And we end up forking on the different versions of history. Whose is correct? Now, if we're all on Bitcoin Core, well then we all sink or swim together. If there's some weird thing that, say, I don't want to give a specific example, but let's just say if we're all on the same software, then we're all seeing the same version of history. But if my software does something different than yours, then whose is right? So there's an argument that the network becomes more fragile the more implementations we have. But in practice, running a full node is just like it's a burden. We're talking about 200 gigabytes of blockchain data. It's really nice software. Like the initial block download sync time has gone down over time. It's just amazing. Like the Bitcoin blockchain keeps getting bigger every month, and the time to sync it is decreasing. I don't know how long that will hold for. I'm surprised it's held for as long as it has. There's not that many optimizations left. So it's a lot easier to like boot up some light client and be ready to go in 30 seconds than to buy some decent hardware and wait many hours for it to sync. So I think that if you push people to only run their own full node, then inevitably what they do is just say, oh, this is complicated, and I'm going to store my Bitcoins on Coinbase. And that's like catastrophically bad. So I think there is a middle ground where, don't do this if you have $10 million in Bitcoin, but if you have like $10,000 in Bitcoin, maybe it's totally reasonable to not run a full node. As long as you have the keys. Not your keys, not your Bitcoin.